All right, today we're going to dive into what is basically a technical detective story. It's pretty fascinating. We're going to follow the digital breadcrumbs to see how a regular old Web 2 domain can be securely tied to a Web 3 identity, all by solving this one cryptic puzzle hidden deep inside the internet's plumbing. So let's jump right in. This right here is the million-dollar question. Or, maybe the $0 question. See, in the world of blockchain, pretty much every little action costs gas. It's a transaction fee. But what if there was a way to prove you own your domain name to the Ethereum Name Service, or ENS, without ever having to touch the blockchain or pay those fees? That is the exact challenge we're tackling today. So here's the mission. If you choose to accept it, we want to build a bridge between two totally separate identities. We're taking a classic domain name, preferido.us, a standard web address, and we're going to cryptographically prove that it belongs to the same person who owns the Web3 identity, neutre.eth. It's all about creating one unified digital identity. Okay, so to make this happen, you've got to know the three key players on the field. First up, you've got DNS, the domain name system. It's basically the internet's phone book. It translates names that we can read, like preferido.us, into IP addresses that computers understand. Then there's DNSSEC. Think of it like a digital notary public, stamping those DNS records to prove they're legit. And finally, you have ENS, the Ethereum Name Service, which gives us those human-friendly usernames for the Web3 world.
You know the saying, right? Before you can build a bridge, you got to have a solid foundation. Well, our story kicks off on June 18, 2025. The domain, preferido.us, is up and running, but it's missing this really crucial security layer. It's kind of like having a house with a front door, but no luck on it.
So check this out. This is where we start, according to the VeriSign DNSSEC debugger. Just look at that left column. No DS records, no DNS key records, no RRSIGs. These are all the digital keys and signatures that make up DNSSEC. And right now, they're just gone. The whole chain of trust is broken before we've even started.
Okay, so step 1, enable DNSSEC. Simple enough, right? Well, not so fast. When that switch was flipped, something weird happened. Instead of getting the all clear, this really strange, very specific error message popped up. And this wasn't just some random error, it was a clue. And just like that, the investigation was on.
And this right here, this is our central mystery. This one line from the terminal is the heart of the whole problem. It's an extended DNS error, and it's basically screaming at us RSIGs missing, specifically for a key with the ID 2751. It's telling us that a critical piece of the puzzle, a specific digital signature, is just not there, even though it's supposed to be.
So, time to put on our detective hats. To solve this, first things first, we've got to figure out what in the world an RSIG even is. And more importantly, why does it matter so much that the one for key 2751 has gone missing?
Okay, so an RRSIG, or Resource Record Signature, think of it as the absolute key piece of evidence in the DNSSEC world. You know how we said DNSSEC is like a digital notary? Well, the RRSIG is that notary's official embossed stamp. It signs a DNS record guaranteeing that the info you're getting is the real deal and hasn't been messed with by some attacker. And our error, it says that stamp is missing.
And this table, it just lays out the problem perfectly. The parent zone, .us, says there should be two keys on record, 41969 and 2751. And the domain zone records agree. Yep, both keys are there. But, and this is the whole problem, when you look for the actual signatures, the RRSIGs, only key 41969 has done its job. Key 2751 is there, but it hasn't signed anything. It's exactly like having two security guards scheduled for a shift, but only one of them is actually bothering to check IDs. Not very secure, right?
So what was the culprit? Well, the most likely suspect was an incomplete automated key rollover. Basically, a new key, our mysterious 2751, was probably added, but the system just failed to finish the job and actually use it to sign things. Once that was figured out, the fix could be deployed. And that right there, that was the big aha moment.
And check this out, the beautiful after picture. On the left, you see the problem state with just one lonely signature. And on the right, as of June 29th, look at that, multiple RSIGs. The missing signature is now in place, the chain of trust is whole again, and that cryptic error message is history. Boom, the foundation is finally rock solid.
All right, so now that the DNSSEC foundation is actually secure, we can get to the really exciting part, building that gasless bridge over to the Web3 world. Now we can finally connect preferido.us to nurture.eth.
And what's the result? Well, this quote from the source document really says it all. Success, your domain is now fully gasless ENS enabled and DNSC signed. Love to see it.
So you're probably wondering, how does this magic trick actually work? It's honestly surprisingly simple and, well, elegant. First, you add a special text record to your domain's DNS settings. Second, because we just fixed DNSSEC, that record is now cryptographically signed and verifiable. Third, the ENS system can just read this public data off-chain, meaning not on the blockchain. And fourth, because of that trusted DNSSEC signature, it can accept it as truth without needing a slow, expensive on-chain transaction.
And this final checklist, it's basically our victory lap. DNSSC enabled and working correctly? Check. The special text record for ENS is in place? Check. The all-important RRSIG signatures are there? Double check. The domain is now ready for that off-chain, gasless resolution. We are green across the board. All systems are go.
Okay, so let's be super clear here. That proof of ownership part is totally gasless, which is huge. But we need to talk about what that means for the whole setup. If you want to fully import your domain into ENS so it acts just like a native .eth name, for things like getting your wallet to show preferido.us, you do still have to interact with the blockchain. That usually takes at least 3 transactions, which, yes, have gas fees. The key innovation here is making that first critical link totally free and totally secure.
And that pretty much wraps up our deep dive detective story. We've seen how getting into the weeds of the internet's plumbing can solve this really critical problem, building a secure bridge between the world we know and the world that's coming. So it really leaves you wondering, right? Now that we know this is possible, what's next? What kind of cool new applications and identities are people going to build on top of this?